Imagine a future where Mars isn't just a dusty red desert, but a place with lakes, trees, and people walking under a soft sky. Is that only science fiction, or could humans really reshape a whole planet? Lots of people talk about traveling to Mars. The bigger question is whether we should change Mars, and how to do it carefully so we don't repeat mistakes from Earth. Terraforming means changing a planet so it's more like Earth. For Mars, that means three goals: warm it up, make the air thicker, and create a cycle of water and life. First, let's check what Mars is like today. It's cold, about minus 60 degrees Celsius on average. The air is super thin, mostly carbon dioxide, less than 1% of Earth's pressure. Water is mostly frozen as ice, and there's lots of radiation because Mars doesn't have a strong magnetic shield like Earth. Gravity is only about 38% of Earth's, so you'd weigh much less. The two biggest hurdles are energy and ingredients. We need energy to heat a planet, and we need the right gas ingredients, like nitrogen and carbon dioxide, to make thicker air and weather. One warming idea uses super greenhouse gases. These are man-made gases that trap heat really well. Robotic factories on Mars, powered by big solar panels or small nuclear reactors, could make these gases and release them into the sky. Another idea is giant mirrors in space. They would reflect extra sunlight onto Mars to start a slow thaw. But there's a catch. Mars might not have enough easy-to-reach carbon dioxide to build thick air, so we may need extra air stuff from somewhere else or a different plan. One option is to bring in icy visitors. Guided comets and ammonia-rich asteroids could be steered to add water and nitrogen. Ammonia breaks down into nitrogen and hydrogen. Nitrogen is a safe filler gas for air, and plants need it. Another smart path is called para-terraforming. Think world houses. These are huge domes or sealed valleys with clear roofs. Inside, air is comfy and warm, while the rest of the planet changes slowly. As pressure rises, liquid water can last on the surface. At first, it would be quick puddles. Later, with a few hundred millibars of pressure, still much less than Earth, we could have stable lakes and gentle rain in some places. Radiation is still a problem. Early towns would likely be underground, inside lava tubes, or covered with thick soil for shielding. For the big picture, scientists have proposed a huge magnetic shield placed between Mars and the Sun to push away the solar wind. That could help Mars hold on to its new air. Life comes in carefully. We'd start with tough microbes and helpful bacteria that can live in the cold and thin air. They'd help recycle nutrients, darken bright ice so it absorbs more heat, and slowly make oxygen. Plants would come next, growing in sheltered basins once temperatures and pressure are safer. Breathable oxygen is the long game. Even with help from biology and sunlight, building up oxygen to Earth-like levels could take thousands of years. But long before that, people could be outdoors with simple oxygen masks if total air pressure is high enough. All of this needs serious power. Mars would need a huge energy grid, small fission reactors at first, then massive solar farms, and maybe fusion one day. We'd make as much as possible on Mars itself. This is called using local resources. That means mining the soil for metals and ice, splitting water into oxygen and hydrogen, and building glass, plastics, and parts for domes and pipes. Timelines are measured in generations. Warming could take centuries. Thickening the atmosphere could take longer. Making lots of oxygen might take millennia. Think of it as a staircase. Each step makes Mars a little easier to live on. We also need rules and ethics. If Mars has any native life, even tiny microbes, we must protect it and study it. Who decides what changes are okay? A shared stewardship plan matters as much as any mirror or reactor. We must manage risks too. Planets are complicated. If we heat Mars too fast or change the chemistry the wrong way, we could set ourselves back. Para-terraforming helps, safe cities under protection, while the planet-wide project moves slowly and can be adjusted. What might success look like in a few centuries? Lakes inside craters, windshields around hardy trees, a softer sky, and people walking outside with light gear instead of bulky suits. Why try it all? A second home spreads risk for our species, opens new science and industry, and teaches us how worlds work, lessons we can use to care for Earth better. Terraforming Mars isn't one giant leap. It's many doable steps. More power, more useful gases, smarter biology, better shielding, and wise rules. We may never make a twin of Earth, but we can make Mars more alive than it is today and become better caretakers of every world we touch.